Good morning, everybody. So I don't know because Xiaoling just say a lot of things in French. I cannot understand. So firstly, I would like to have a brief self-introduction by myself for my background, so that you can know me a lot. In fact, my major is mathematics. After that, for geography. After I got my PhD, I went to the lab, the laboratory, key laboratory of information engineering in Wuhan University. In that laboratory, in fact, is the #1 for the remote sensing, GIS, and GPS technology in China, also very famous in the world. So after I got my PhD, I went there to study geographical issues using mathematical method and combined remote sensing, GIS technologies together. So I think these are very famous, very important tools to resolve the geographical issues. So this morning, I think I may just focus on one of my team's research results, especially for the Poyang Lake, and also want to focus on the dynamics, because for the Poyang Lake, dynamics is very important thing, and is also a very important research basis for all the things, all the ecological issues in Poyang Lake. So firstly, I would like to introduce you some things related to Poyang Lake and its watershed. From this paper, you can find in China, in fact, lakes, the waters should be a big problem in. From this figure, you can find before 30,000 years ago. Here you can see is for high level waters, middle, lower. You can see the water should be no problem in past time, but you can find here is 3,000 years before. Water should be a problem. Now is a big problem. For example, here is Dongting River, Dongting Lake. In Dongting Lake, in 1825, you can find is a big lake, very large, but now is shrink until now. It's just a second freshwater lake in China. So here is also an example for the Honghu Lake. Is the largest lake in Hubei province, my hometown, my home province. You can see the wetlands impacted by human activities heavily. WWF issued some project in this lake for the eco restoration. After eco restoration, you can find the wetland is very good. But in last year, because of the serious drought, it was destroyed. The wetland was destroyed. You can see last year for the Gorges station, no waters. You can see some pictures for the wetlands like this. So for the Poyang Lake, what's happened? In fact, Poyang Lake is along the Yangtze River. Here you can find the Yangtze River. It's the largest freshwater lake in along the Yangtze River, also in China. Here is the Poyang Lake watershed. Poyang Lake is here. It connected to Yangtze River. So for the Poyang Lake, the great characteristic is great changes for the inundation area. One, it is in the largest. It can be more than 3,000 square kilometers. But for the smallest areas, it's just less than 1,000 square kilometers. For this lake, the watershed is more than 160,000 square kilometers. The water in the Poyang Lake is flow from south to north, discharged and then discharged into the Yangtze River. Here is Yangtze River. So for the Poyang Lake, water comes from precipitation, mostly from the watershed here, for the watershed. In the watershed, there are 5 main rivers. Mostly the water flow into the Yangtze River. Sometimes, especially in the flooding area, the Yangtze River, the water level of Yangtze River is very high. There may be some water inverse flow into the Poyang Lake. So in this kind of lake, the wetland, we have the very famous wetlands. In the wetlands, there is 2 important things. One is for the migratory bird, the bird from the Siberia, every winter, and also has a big problem for the schistosomiasis. So in this area, in fact, the economic development is not so good. So you can see some pictures for the Poyang Lake wetland. Here is a picture taken from the airplane in the winter. In the winter, you can see a lot of birds come here. And here is a picture for the wetland. So from this map, you can find wetland have greatly seasonal inundations. Here is the inundation time for different days. You can see from several days to more than 100 days. So that means for the Poyang Lake, almost the whole areas inundated for different times. And also, it's hard to find the permanent water bodies in this area. So in this view, we can say all the Poyang Lake just as a wetlands. Because the Poyang Lake is very big, so from south to north, the water level, in fact, has quite different when it is covered by the water body. So that means there is a gradient. So because for the Poyang Lake, just several gauge stations, we can find 6. It's not easy to get all the water levels for the lakes. So it is important. We need to get the data by other ways. Remote sensing is a good thing to get it. So you can see here is just a work to get the water levels from the satellite altimetry. This work also have some French people to do this work. And also because the wetland is changed greatly, so how to define the boundary for the wetlands, also for the lakes, is a big challenges. So we also find different kinds of methods to do it. So the mathematical methods is also very important for the research. And here you can find the change in a year. In the flooding area, in the flooding period, the area is very large, but in the dry period, it's very narrow for the lake. And also for the flooding period may have floodings. And also these years, in fact, the serious drought occurred frequently. Along the Poyang Lake, there is a lot of different kinds of human activities. For example, sand dredging and reclamation around the lakes for the local people, and also have some urbanizations. So what kind of forces to drive the changes is also a big thing we hope to do. You can see from this this work, we use remote sensing and try to know why the wetland changed. You can see when the wetland decreased, the urbanization expanded. It has a good relationship. That means human activity has a great impact for the wetland. Also, because the water depths changed greatly, so also get a lot of kinds of wetland ecological problems. Here is some result we got for the ecology. And also because of the in the watershed there is some mining, so heavy metal pollution is also a problem. Not so big, but it's also need to be focused. And for the bird, we got some observations with NASA. In fact, it's a project supported by NASA, and some of our people joined to do it. You can see we traced the birds find is come from the north, and when the bird come here, it may have some introduction interaction with poultry, for the local poultry. So that should be a great risk for bird flu. Also, in the wetlands area, the snail has a special distribution, and for the snail, there may have some schistosomiasis problem. Is a kind of disease in this area, has a great impact for the human beings. You can see in near the Poyang Lake, you can see the red colors is that means uncontrolled in this area. The people may face to disease for this disease, and other area has different kinds of different degrees of control for this disease. So we also need need to study how the snail distribution will be changed, because when the water depth changed, the distribution, the spatial distribution also changed. So from these things, we can find a lot of problems need to focus. So in this, I think the dynamics should be the first thing we need to know well. So we focus this research for about 2 years and then get some results. So this morning, I would like to focus on the dynamics. Firstly, the dynamics we may focus it in inundation area, bottom topography, water quantity, and water quality. The four points. Firstly, we know Poyang Lake is one of the most frequently flooded and drought area in China. Its rapid changes plays an important role in affecting the wetland ecosystem as the habitat for migrating birds. In fact, Poyang Lake is influenced by subtropical monsoon, so it has a wet season and dry season. For the wet season, except for the great rainfall, and also Yangtze River has a high water level. It also increases the lake's inundation area. So for the dry season, because of the Three Gorges Dam, the water level in the Yangtze River may be lower than before. So the streak for the lakes should be more serious. So the drought also seriously occurred in this area. So because the lake's rapid and significant fluctuation in a short time, so we need to find a good way to capture the dramatic changes. Here, you can see we take the time series data from 2000 to 2010, and then we find MODIS is a very good remote sensor to get it, because every day we can get 2 time images to cover this area. So as this area has a lot of time for the cloudy, especially in the summer seasons, so we in this time series we just selected 620 images to delineate the inundation area. From our work, every year we get the largest area for the water body and the minimum, the maximum, the minimum area. From these images, these results, we can find for different years, the maximum and minimum areas may have about 2 to 3 fold for the changes. For the whole area, you can see this result. For this result, for the time period, this result we make a result for the maximum area and the minimum area, you can see almost all people or all areas. For the maximum and the minimum should be has 14 times different. From this result, we got the time series for a calculation for each month. From this, we can find the monthly minimum inundation area. You can see in different months has different results. From here, this one is September, October, November, December, and January, February, March. We can find this, all these months, less than 50% of the inundation area between these months. You can see the red color. And for the maximum inundation area, you can see from this June, July, August is more than 50% of the Poyang Lake was inundation, even at minimal inundation. So the maximum minimum ratio ranges between 1 to 4. It suggests a significant inter-annual variation for all months. So here is a table you can find. You can find a great change, in fact, occurred in August to September from the ratio from 1 to 1.85 to 3.64. That means a sharply increase for the maximum minimum ratio occurred from autumn to September. From these figures, you can find the minimum area and the maximum areas change. And for the mean, you can see some decreasing trend. That means in Poyang Lake, for our study period, the water area may decrease gradually for a little. Here is a result for the monthly precipitation in Poyang Lake watershed. We can find, in fact, for the watershed, the largest rainfall should be in from here is April, May, June. But from this figure, you can find the blue color should be the maximum for the inundation area. The red is minimum. So you can find the maximum inundation area always in here is months, mostly in July to here is July to September. Why there is difference? From this figure, we can find in different time periods, the water area and precipitation has some relationship. From Jan to June, this one is precipitation, and this one is for water area. You can find a good relationship. Correlation is very good. From October to December is also good, but from June to September, quite different. That might show Yangtze River impact for the Poyang Lake inundation area. So here just to show a picture for the serious drought in 2011. You can see the water just like a prairie. So a lot of reports for the media or other kind of things to reported this drought, but how serious? No scientific data to support it. Just take a picture, take a photo to show it. And most people say it's an effect of Three Gorges Dam. Why? No explanation for the more scientific from more scientific reviews. So we did some results by remote sensing. From this result, we can find the inundation area for May in Poyang Lake. The average area should be like this, but last year, just the red coverage is for the water bodies. So from this, you can find how serious for the drought and where it happened for drought. It's very clearly. So remote sensing is really a powerful tool for this. And in fact, there is also some figures, some reports for the drought and flood events in this area. Just to show you how the loss is. You can see in 2007, because of drought, more than 10 million people have a problem for the water. And in 2007 and 8, there is big losses in this area. So from these results, we just want to say what's the impact for the Three Gorges Dam, for the impact for last year's drought. From here, we have two kinds of data. One is for monthly mean for the water. This figure just shows the water area, and here is for the precipitation. The precipitation rate is from remote sensing. We got the data from remote sensing. So you can find this one is for the average one, and here is the monthly mean for every year. We can find in the time series there is this kind of situation, but in 2011, the last year, we can find the water area decreased greatly and has a difference with the average. Here you can find for the precipitation is also decreased. So from this figure, we can find low precipitation might be a great reasons. So how the Three Gorges Dam has the impact for the drought, we may need to carefully to evaluate it. So The second dynamics I would like to show you is the bottom topography. In fact, because Poyang Lake is in a dynamic, highly dynamic, so it's not easy for the traditional measurements to get the body topography. But for remote sensing, it's also quite difficulties because it's so turbid. It's a limit for the remote sensing use. So because for the high dynamic, for the Poyang Lake, the watershed has a great soil erosion, and also for the Three Gorges Dam's impoundment. So the plus to the sand dragging in the lake, many changes has occurred in the lakes. So we need to catch the changes, the dynamics, and also it's not easy to get a good way. So we think about these things. And also we have the sonar and go to the lake to get some field measurements and get the measurements as a validation. And then we also analyzed what kind of sensors should be better for this area. After the analysis, we find Modi's should be a good sensor to do it. From this work, we can find because Poyang Lake has a seasonal fluctuation, so every year, that means every year it changed, the water body boundary changed greatly. So we may get the water boundary for different time period, but it's not the icebergs, because from south to north, from this figure we can find in different time. Here is south part. From south part to north part, the lake was covered by water. The water level is quite different. That means the water level has a gradient. So you can see here is 2000 and December. Is December, in December. This one is in March, and here is in June. The water level is high enough, especially when the water reverse flow from the Yangtze River. The lake's water level may be flat, but other time it should has a gradient. So when we got the boundary from the remote sensing, we also need correct it. So we need to take some field measurements from the gauge station, and also need to go to make measurements by fish, by ship, by boat. So when we do all the things, we get some measurements for the validation. We can find we get three transact 1, 2, 3 here, and got all the points here. We can find the measured and the derived data has a good relationship. Here is the red one is for derived, blue is measured results. From this figure, we also find for the bottom topography, the elevation is mostly from 12 to 7. So we can get the bottom topography for every year. From these results, we can find Poyang Lake is become shallow year by year. So because this kind of data is quite different to difficult to get. For Jiangxi province, 2 years ago, the issued kind of project that want to get this data. They make a large of money, want to get it, but now still no complete result to be got. So from this research, we can, I think, I also want to develop a system to issue to the government department and hope to send them for the results, for their reference for the decision making. This is a result for the bottom change. You can see year by year the changes, and this result is for the total changes for the whole lake. From this table we can find for the changes we divide it into increase and decrease. For the percentage, for increase percentage, you can find mostly for the years is more than 30%. For the whole changes, the increase area is more than 50%. It also showed a great increase for the bottom topography. For this work, we also want to know why the suspended sediment has that kind of a special distribution for the lake. For here, we can find from the rivers, tributaries, and also for the north part, here may have the sediments from the watershed, and for this area should be for the sand dredging. The human activities should be a great impact for the suspended sediment concentration changes in the lake. So once the water quantity is also very concerned for the governmental officials. Mostly, we just got data from the gauge station, but here we find it is impossible to estimate water budget. Firstly, it's no reliable measurements of the lake outflow to Yangtze River. And second thing is the bottom topography is very complex. And the inundation area is also in the high dynamics. That is some limits. So we hope to use the remote sensing to get the outflow So in this work, we use this kind of calculation to do it. Here is the groundwater flux, because it's just has 1.3% of total water resources comes from the groundwater, so we may think this is 0, because this kind of data is also not easy to get. And for this part, we need to use the water level height and the bottom topography information to get it is from remote sensing. And this one is for from the water from 5 main rivers in the watershed. And here is in the lakes precipitation and evaporation. According to calculation, we get the result like this. It's very exciting. This one is for the lake volume and water area. In this result, we can find in 2003, there is a great outflow. This outflow means, in fact, in the later I'll show you some results for the precipitation. You can find this year, the rainfall is not so large, but the outflow is very large, just because in this year, Three Gorges Dam impounded in June. So in July and August, Poyang Lake poured the waters greatly, so it becomes drought. That means also a great impact for Three Gorges Dam for the Poyang Lake. This figure, you can find the outflow is very large here in this year. And we can find the water level decreased from July 15th to August 15th. You can find a great decrease occurred in this year. From these figures, you can see here is the annual precipitation for the 2003 is here, and annual outflow you can find it has in fact it has a decrease, and also for the runoff coefficient you can find from this year before this year is larger than after this year. That may have some meaning for the Three Gorges Dam. That means Three Gorges Dam may change the type for the runoff coefficient in this area. So we need more research to support our viewpoints. From this figure, you can find annual inflow and annual outflow in all the years has a good agreement. Just for the 2003, there is more than around 15% higher for the outflow than the inflow. It's also we think is Three Gorges Dam's force. So the last dynamic, I think, should be the water quality. Water quality is a great thing we need to focus. For this work, we do a lot of different kinds of in-situ observation. In the lake, we just can find this kind of boat for the measurements. So this is one-day measurements for the lakes. We have different kinds of instruments. We can get the data through driving a car like this, and in the lake we have a lot of instruments to get the data, and also can sampling to have analysis in the laboratory. And we also have some sensors to get data from airplane, and also can receive the satellite data, and also have some good computing resources. And here is our receiving station. This is for MODIS, and this is a new one. We got the images from Thailand satellite. This satellite is was supported by Europe. Is mostly like spot, this one. And for this instrument is want to get some result for the air characteristics, for the optical depths, is especially for the remote sensing retrieval analysis. And here is some data for the meteorological data. And this is some results. We develop a software to analyze the data. And here is some sensors to measure the remote sensing reflectance. And here is a result we can find. When we get this result, we will have some analysis. For example, for the materials in the lake, what kind of things in the lake we can analysis like this. For example, if it's organic sediments, should have a peak in this area. If the sediments is inorganic, the peak should be here. So from this analysis, we can find in Poyang Lake should be inorganic sediments. Also, from different curves, we can find different sediment concentration. For this one, we have a comparison with the Y-size measurements. We can find the turbidity is very high. It's more than 60. And for this curve, it's just around less than 20. For this one, it's around 10. This is a system we just got with data for the theoretical analysis for the water quality parameters. And here is some measurements. This one is for the for sediment size analysis, and for this the Y-side we can get 6 parameters at the same time. And here is a sampling tool. Here is some instruments. We take the lab analysis. Here is different kinds of in-situ measurements in the Poyang Lake. This one is in the, 2005, 2008, 2009, and last year. So we just focus on the flooding period and dry period. We want to find how we can the water quality changed in different time series. For the remote sensing, I don't want to say more. I just want to show for different methods will have different results, even for the same data set. So that should be a big program. So we need to take more in-situ fields, in-situ measurements. This is the result. We take the Landsat TM to get the result. And atmospheric correction is kinds of important analysis for remote sensing retrieval for the water quality. Here is parameters for the suspended sediment we got from the Chinese sensor, remote sensing sensor, HJ. You can see this is different concentration for suspended sediment, and also can see the pictures, the photos for the water quality in this area, and for the clear waters like this. And before we got the suspended sediment, we think is very important indicators for the water quality. We also need a lot of kinds of remote sensing analysis. For example, we need to remove the atmospheric impact. We take these measures. For example, here, because here is 0, we just minus it and remove the atmospheric effects, and also need to find which band should be better for the retrieval, for the analysis, and also want to find if the sediment size has any kinds of impact for the retrieval algorithms. After that, we get different kinds of composition for the methods and select the best one. And then we can find the results has good agreements with the measured data. And then we can get a spatio-temporal distribution for the suspended sediment in the time period. We can, from this result, we can find here is 2003. We can find since 2003, the suspended sediment in the whole lake is significantly increased. We also divide the lake from here, divide the lake into two parts, the north parts and the south parts. You can find for the north part and the south part, north part has a high concentration for the suspended sediment. South part is lower here. From these curves, we can find in the time series the difference between south and the north. The suspended sediment concentration before 2003, the change is not so big. But after the year, great changes. And also the north part has a high concentration, very big. So what's the reason? We can see in the north part, we make the analysis. We also can define any place and any time for the changes like this, and also has the anomaly from these figures. In fact, in this area, the grid increased for the suspended sediment is mostly because of management policies change. Because since these years, the Yangtze River has a ban for the sand dragging. So most boats come to Poyang Lake for that activities. So that should be great reasons for that. So here is some images from download from Google Earth. You can find from the high resolution image, we can find the boats through the images. You can see the boats. From these images is the Landsat TM. We can find here is the north part in this area. In this area, in 2000, in the image, we cannot find the boats. But in 2005, you can find a lot of boats in the lake. So according to the images, we calculate the boats quantity and then have this result. Here is our derived suspended sediment by remote sensing, and this result is boat numbers we count from the remote sensing. We find when the suspended sediment increased, the boat numbers also increased. There is a good agreements like this. Because Poyang Lake is very shallow, we also try to find other reasons if it is more important than this one. From here, we can find some results. This is for the sediments, and this one is for precipitation. And this one is for the wind, because wind may make some resuspended. We find no significant trend for these reasons. So for the Poyang Lake water quality, we also hope to integrate hydrodynamic modeling to do it. Here is some modeling results for the current in wet season and dry season, and also have some results for the water quality parameters. Here is suspended sediment is for the nitrogen, phosphorus. We also think for the Poyang Lake's dynamics, it should be comes from the whole watershed's impacts. For example, here is a result for the land use changes, land use and cover changes for the 10-year span. From this figure, we can find if no changes for the Landsat and the cover types, the rainfall and sediments should have good agreements. But for these curves, we can find rainfall. This one is for sediment. You can see whenever the rainfall changes like any types, the decrease in the time series is really decreased in total. That means watershed management has a great force for the sediment issue. So we also to do some work for the watershed research. In the watershed, we try to develop a kind of rainfall runoff model to analyze the surface process like this, and also take a small watershed to have a test our method, and also combine the USLE soil erosion model with the sediment delivery ratio, have an analysis like this. And then for the whole watershed, we develop a round of producing and coverage modeling and get the data, and then analyze all the parameters, and then get the soil erosion change in different times. We can find here is soil erosion decrease and increase, and also get some soil erosion intensity. And this one is for some calculation for the pollutants loss. And here is a result for the nitrogen and phosphorus. And we can get the result for different sub-watersheds. And then we can calculate the dissolved nitrogen and phosphorus. We can estimate the pollutants load. So for this kind of work, this time I come here for three months work. I also work with Jean-Luc's team members to do a lot of things. And I think this afternoon we may have more discussion for that. So I think integrated watershed ecosystem management should be very important for this area. We need to take the parameters through measurements, different kinds of measurements from satellite, from in-field. And also, for all data, we need to establish models to retrieve the information. And then we need to analyze the eco program, and then get the watershed management measures. So in fact, now we also want to establish a system to get data from satellite, from in-situ measurements like this, and develop a system to get all the data in time and process it in real time, and then establish a system to manage all the information. Here is the information system we developed for Hong Kong. Here is the system. In this system, we also integrate some water quality analysis models in it. And here is the software we developed for disaster mitigation. We just need to click simply and then get the information from data. Like this. So in conclusions, I think Poyang Lake and its watershed is a complicated wetland watershed ecosystem. It is facing a series of eco-environmental crises caused by physical and anthropogenic factors. Water quality and quantity are critical indicators to the ecosystem, and remote sensing should be a useful tool to catch their dynamics. So for the Poyang Lake, eco-environmental health is a big challenge, and surface processes should play key roles in the watershed management, and the ecosystem dynamics need to be monitored and managed by integrated remote sensing and hydrodynamic models. So for our work, especially for our, if we want to integrate old peoples from China and French, how we should do, I think I just have a simple consideration we may discuss this afternoon for the more detail. So we may take water cycling and governance on the changed environment as key points, and then we may analyze for three kind of flows. One is for physical components. We may need to have a good data and information to analyze our further research. We need to know river and the lake discharge. We have done something like I said before. And we also need to know the dynamics for the river and the lake morphology, and also need to know water storage volumes. And we can make an eco-hydrodynamic interaction for the physical and biological, biogeochemical processes. In this issue, we may focus on species richness, habitat quality, water quality, and other things. Human activity, especially for the economic activity and the water usage, should be a big problem for this area. So we may need to know water-related institutions, water engineering works, and water use sectors. For the Poyang Lake, now the government in the Jiangxi province try to establish a kind of dam in the Poyang Lake. That should be a big thing, I think, for the ecological challenge. So for these two things, we may take water resource control as key points, and for these 2 points, we may take ecological restoration as our focus. So for these two, climate change should be a great impact for it. So how we analyze all things to get the right information for this. We may take Poyang Lake and its watershed as a whole system, and also consider what's the impacts for the Yangtze River. So it's complicated issues for the scientific research. So that's all, merci.